Sorry, yeah. I just copied back the latest version of our exercise into my local Visual Studio. So I can continue from there, but as you saw, it's very easy to switch around between different tools. Just one thing for those that use the local compiler, when the compiler runs successfully, it will create a new directory in your project called fish generated. And in that directory, you will find all the resources that the compiler created, particularly your patient resource. So that's basically the local version of the right-hand pane that you have in the online tools. Instead, you will find JSON files in that particular folder. And every time the compiler runs, it will delete these files and recreate them. So an error that occurs quite often, for me at least, might be a Windows issue, but if I have that file open like in an editor because I was looking at the FHIR resource and then I run the compiler quite often returns an error because it couldn't delete the resources. So if you see that kind of problem, you probably have some notepad or something open, or maybe even if you have the folder open in the file manager, that might also cause an issue. Just close any other programs that might access the folder structure and then rerun the compiler, and it should work just fine. All right, so as I said earlier, knowing how to create an instance of a FHIR resource is pretty much the whole deal, right? Because that's what you do with FHIR Shorthand, you create FHIR resources. But there's a bunch of special syntax to make it easier to create specific types of instances, for example, profiles. You could theoretically create a profile in the exact same way by using the instance command, give your profile a name, and then say instance of structure definition. But when you create a profile by authoring a structure definition, things are going to be actually quite complex. Let me just show you a structure definition in R4 real quick. And you can see that whenever you create a profile, you will have to populate a lot of metadata about what is profile actually supposed to do. And then for every element that you want to put a constraint on, you will have to create an element definition that will set things like cardinalities, flags, bindings, all that stuff is happening in the structure of that element definition. And that would be really, really complicated to create this as an instance of a structure definition. Instead, what FHIR Shorthand allows you to do is to use a different header and say that this time you want to create a profile instead of an instance. And again, the first thing you do is you assign a unique name to your profile. Let's say this is my first patient profile. And the second command in this case is you have to say what you want to create a profile of. And the keyword in this case is parent. So you're usually deriving your profile from a parent resource. For example, if you want to create a profile on patient, the parent is the structure of a patient, but you might also create a profile on top of another profile. So in that case, the parent would be the other profile that you would to put constraints on. But let's keep it simple for our first exercise and assume that we want to create a profile on the resource type patient. So now we can use the exact same syntax as before and address certain elements of the patient that we want to put constraints on. So the path that we can use now is the path of the patient resource. We do not have to set path of the structure definition, but instead we can say, for example, that patient birth date should have a minimum cardinality of 1. So if you want to make this element mandatory, you just type the name of the element from the parent resource that you want to put your constraint on, and then with a space behind it, you can add your minimum or even your maximum cardinality, if you like. If you want to leave the maximum cardinality unchanged, you can just omit the number. Alternatively, if you want to leave the minimum cardinality unchanged and just enter a maximum cardinality, it would look like this. Whenever you enter a cardinality that is identical to what the FHIR specification says, the compiler will just ignore it. Like in this case, for example, putting a maximum cardinality of birthday to 1 will just do nothing because you're not really putting a constraint that is in any way different from the FHIR resource. So this wouldn't have any effect. However, increasing the minimum cardinality to 1 will put an actual constraint on this profile. And we don't really have to do anything else in order to create our first profile. We can actually run SUSHI right now and see what it creates. Okay, that was successful. So now in my resource folder, you can see I have 2 JSON files right now. I have my patient resource and my structure definition. And the results would have been exactly the same had I chosen to create a new fish file for my profile. It wouldn't have made any difference whatsoever. That's just personal preference on whether you'd rather have one huge file or multiple smaller files. That's totally up to you. So let's take a look at the structure definition. And you can see that the compiler has actually done quite a lot of work from that one single command that we actually given it. It already populated some of the metadata. Again, it used the name that we assigned to our profile as the ID for the resource, same as it did with the patient example. But it also used the name that we assigned in the header to create a canonical URL. And now it also used the canonical root that we have in our SUSHI config file. So what the compiler will do, whenever you create a definition resource that has a unique canonical URL, it will take this string from your configuration file, add a slash, then add the name of the resource type. In this case, it was a structure definition, slash, and then it will use the name that you assigned to your profile. So in our case, the canonical ended up being, this part is from the SUSHI config YAML. This is the type of resource we created. And in the end, we have the name that we assigned to this resource. So whenever you use FHIR shorthand, you don't have to really pay any attention to the canonicals. They will automatically be assigned by your compiler just from the names that you choose for your artifacts. Since definitions also have a computer-friendly name, this will automatically populate it again with the name that we assigned. Status is automatically set to draft unless specified otherwise in the config YAML. FHIR version is also taken from the config file. Since we decided that we want to use FHIR R4, it's set appropriately right here. Kind is a resource profile. It's not an abstract profile. Again, these are all default values that are automatically populated unless you tell the compiler to do otherwise. We have the type, the base definition, which is the canonical URL of the patient resource. And these are basically all default values that are automatically populated. The actual instruction that we gave is part of the differential. The differential is now basically listing everything that differentiates our profile from the underlying definition of a patient resource. And the only change that we made is that we increased the minimum cardinality of the patient birth date element. And now you probably understand why it's so much easier to use the profile header instead of the instance header, because if we used instance of, we would have to assign all these values using FHIR shorthand instructions. Using the profile header will take care of all of that automatically, and we only have to pay attention to the actual constraints that we want to put into our profile. So using that syntax, which is path of the element that you want to constrain, space, and then minimum cardinality dot maximum cardinality, that's how you can assign cardinalities for any element in your resource. And if you add another space, you can also assign flags. Most of the time, if you use flags in your profiles, it's probably going to be a must support flag, because you want to label an element as important in your project, in your profile. So this is kind of an obligation for implementers of your specification, that they need to pay attention to this element regardless of whether it's required or not. And adding a must support flag is as simple as adding the MS with a space behind the cardinality. You can also assign must support flags without changing cardinalities. For example, what's happening? I don't want to stop doing that. Thank you. Let's say we want to make a gender just must support without changing the cardinality. We just want to label it as important in our context, but it still can be missing. So we don't want to change anything about the fact that the minimum cardinality is 0. And we just slap the must support flag onto this element. That would be the way to accomplish that. And we can again run our compiler and look at the output. You can see that in the background, the structure definition has been deleted. It was striked out. Now it's back once the compiler completes. And now you can see we have another change in our differential for the patient gender, where must support has been set to true. But now we're probably at a point where looking at JSON output isn't as satisfying anymore. Because normally when you want to look at a profile, you're expecting to see a tree view, right? That has all of these changes and flags that you assign to it. So there's two ways to do that. You either have to run the full IG publisher and create the HTML output from your project, which again will take a lot of time to have everything set up so that the IG publisher can run successfully. But if you just want a tiny sneak peek and take a look at what your profile would actually look like if it was rendered, I recommend that you just take your code and copy and paste it into the simplifier playground and run the compiler over there, because that will instantly create a tree view of your profile. In this case, you can see a differential view where all the elements that have changes are highlighted. You can see that the birth date has the minimum cardinality changed to 1, and you can see that both gender and birth date have a must support flag. Again, you can also look at the JSON output, which is exactly the same that our compiler produced. But again, if you just want to have a preview of what it looks like, this is the easiest way to get it. You can also see that it also created a tree view of our patient resource, so you can also look at the instance in this kind of tree representation, which is sometimes really helpful if you want to show examples to non-technical people that don't want to be bothered with looking at JSON or XML code. You can just give them a graphic representation of what the instance actually looks like. All right, now let's assume that we want our example patient be a patient that complies with our profile. At no point at this time are we saying that this instance of a patient actually implements this patient profile. But we can easily do that by simply changing the instance of line. And instead of simply stating the resource type, we can also say that we want to create an instance of my first patient profile by simply putting the name of that profile instead of the just the resource type at the top. And this way, we are saying that this patient is an instance of our patient profile. Let's just see, we have a mandatory birth date, and that's pretty much the only constraint that we have, so this should work with the compiler. Let's check. Yeah, so this again creates our patient instance successfully. The only thing that changes by adding this this instance of profile name is that the compiler will add what we call a conformance claim. Like into the patient metadata, we now have the name of our profile, the canonical URL of our profile added to the metadata of our patient instance. So that's basically just the instance claiming that it is conforming to our particular profile. And the SUSHI compiler will also pick up errors if you create an instance that does not comply with the stated profile. I will just provoke the error by commenting out the birth date. And so now the instance should violate the constraint that birth date has a minimum cardinality of 1. And you will see that the compiler actually registers the error once you actually run it. So there you go. Now we get an error return saying patient birth date has a minimum cardinality 1, but occurs 0 times. So therefore, our patient is invalid, and that will return an error. However, please be aware that running the SUSHI compiler is not a substitute for actual resource validation. The compiler will only detect structural errors like missing elements or mismatched data types. That's stuff that the compiler will notice. It will not do any kind of code validation. It will not pick up invalid codes or, yeah, I don't know. If you if you're not conforming with the terminology binding, and if your code is not contained in a value set, the compiler will never notify you. So you will still have to validate your instance to make sure that really every constraint is fulfilled. The compiler will also not pick up invariants, so if you violate any rules that are part of a profile, that will also not be picked up by the SUSHI compiler. One thing that is actually neat is if you add a mandatory element with a hard-coded value to profile, let's just say we put patient active, let's make that mandatory, and let's also assign this value with a hard-coded true. So by basically assigning a value in a profile, you're basically saying that the value of this element always has to be true in that case. And by saying that, we can actually run our compiler, and normally we would expect it to return an error, right? Because we have a new mandatory element that is not used in our patient instance. I didn't add the active element to the patient instance, I only added it to the profile. However, you can see that the compiler is perfectly happy with our instance. It's not complaining about the fact that our instance is missing the mandatory active element. But let's take a look at our patient and see if anything changed. And you can see that our patient somehow magically has an active element that is set to true, although we didn't really change anything in our example. But the compiler is smart enough to understand that if we say that our patient has to conform to that particular profile, and the profile says that the active element always has to be present and always needs to be set to true, it will just do that automatically, and you don't have to explicitly assign a value that is hard-coded anyway according to the profile, which can be quite helpful at times. Specifically, think about observations, like you have a blood pressure observation profile where you have a hard-coded loin code because it's always the same, you have a hard-coded UCUM unit because it's always the same, and the only thing that actually changes is the reference to the patient and the actual number that you measured. And it's actually going to be very, very easy to create large numbers of examples by just writing 2 lines of FHIR code, because the only thing that you actually have to manually assign is the measured value and the reference to the patient. Everything else is automatically populated by the profile.
Profiles are a repeated field. Is there a way to specify an instance of for more than one profile?
Hold on, if a profile has a repeating element, like if a profile says that a patient has to have multiple names, is that what you mean?
So profile is a repeated field in the specification, so you can have more than one profile for a resource, but I see instance of there looks like it's only for a single entity. Is there a way to specify more than one in FHIR code?
Oh, you mean to say that the instance conforms to our profile and US core, for example?
Yes, exactly.
That's a good question. I'm not really sure, actually, but it's probably quite simple to find out. Let's say this one has a mandatory gender element, and this is my second FHIR profile. And the only way I could think of to do that is either by adding keyword and, which I've never done that before, so I have no idea what's going to happen right now. It might just all crash and burn. Extraneous expecting values. So, okay, the only alternative I could think of would be to have a comma-separated list. But that's probably not going to work, yeah. Hold on, but this it said I'm supposed to use and instead of, right? Use and to list multiple items. That's what I did the first place, but I didn't accept that. However, I'm not sure if that's even supposed to work, because what would the compiler do if it has to create an instance that complies to multiple profiles at once? I mean, there might be contradictions in there. I think that, pardon me?
Would you manually add the profiles to meta?
That's what I was thinking, that the only thing that you could do is to say meta.profile equals canonical of my second profile, which basically manually adds another conformance claim to an additional resource, but that will only create another profile in the output. Although, will it? I don't think it actually will, because we have a repeatable element, and I think it's just going to override the one that's automatically populated. I think we might have to add an index as well to actually make that work, because now we have basically two instructions writing the same into the same. Oh no, it's actually working. Okay, well, I don't know how, but it worked. Okay, so now we have these two conformance claims in that profile, and if you run that instance through the validator, it will actually check both profiles. However, the SUSHI compiler will now probably only check conformance to the profile that we have in the instance of. I don't think that it would pick up errors in the second profile, although that should also be easy to figure out. Let's just remove the gender, which should be fine with the first, but not okay with the second. See if the SUSHI compiler picks that up. Yeah, no, it doesn't. I didn't expect it to. So it uses basically whatever you put in the instance of as instructions on how to build the resource, and just adds the second profile into the metadata, but you will then have to run a validator to check whether that's actually true. Let's just put some comments in case anyone gets confused on what we are actually doing here. Add conformance claim to a second profile. There you go. Now, if my second profile was a profile on my first profile, I would only have to create an instance of the second profile, because conforming to the second profile implies that it also conforms to the first. I wouldn't have to explicitly list both.
Oh, then couldn't you set a default, like the way you set active equals true? You could set meta profile in your profile definition, so it's automatically setting both of them on it. Kind of like a hack around it.
Probably could do that, yeah. Saying, yeah, that should work. It's just, the question is, why would you want to do that? Actually, we have a lengthy discussion in Germany about whether it's actually best practice that when you create a profile to require any instance that conforms to that profile to actually have a conformance claim. Because a conformance claim should never change how a resource is being interpreted. For a patient resource to be conformant to US core, it doesn't have to claim to be conformant with US core. It simply has to be conformant, right? You have to validate it, and if it's okay, then it's a US core profile, a US core conforming patient. You wouldn't reject the resource simply because it's missing a conformance claim. You would instead validate it, and if it's okay, you would accept it, and if not, you would reject it. Other way around as well. Simply because a resource claims to be conformant to US core, you wouldn't just simply believe it. You would still run the validator to check whether that's actually true. So actually requiring your instances to carry a specific conformance claim is not really a good idea. We actually have one organization in Germany that does that excessively, and we've run into multiple problems with specifically that. But that's also because they made the mistake to not only require a hard-coded profile, but also to set the cardinality of meta.profile to 1.1, which basically makes it impossible for any instance to be conformant to more than one profile, which is a little bit ridiculous, but that's something that actually happened. So yeah, I think it's even in the best practice guide, there's a line that says, don't make any assumptions about metadata, because metadata usually is being handled by the server that manages a resource. And an external implementation guide shouldn't make any assumptions on how a server assigns metadata, how it does versioning, what ID it assigns to a patient, stuff like that. So just don't touch meta. That's basically the message when you create profiles. All right, let's go to extensions. Let's assume that we are working for the United Federation of Planets, and we are tasked with creating an implementation guide that makes FHIR usable in interplanetary healthcare communication. So what we need to do is we have to put an extension on the address data type, because in order for an address to be unique, we also have to give information about what planet this address is actually on. That's obviously something that is not covered by the FHIR specification. If you look at the address data type, you will notice that there's really no element that is good to put planet information in. Hold on, let's just go back to our patient. See, let's put some constraints on patient address, and in this address data type, you can see there's lots of elements there, but not really a good place where you could add information about a planet. So we obviously need to add an extension on the address data type. And again, what is an extension if not just another instance of a structure definition? So we could, again, just create an instance of a structure definition, but there's also an easier way to do that in FHIR Shorthand, and that is to use the extension header. Again, first thing we do is we assign a name, my planet extension, and basically what I teach in my trainings is to think of extensions as basically nothing more than a key value pair. Whenever you add an extension, you're basically just adding a key value pair list to your profile. And so every extension needs a unique name, that's the key. And as we always do in FHIR, whenever we assign a unique name to a definition, we use a canonical URL, right? However, we already noticed that we don't really have to take care of our canonical URLs. By giving the extension a name, the compiler will automatically assign a canonical URL. So we don't have to do anything. We only have to pay attention to the value of our extension. And any extension has a value by default. The only thing that is not defined in a specification is the data type for that value. So the only thing that we have to do is to decide what data type our extension should carry. And let's just assume that we just put the name of the planet as a string. That's the easiest way. So all we have to do is to make sure that the value element, which is a choice type, because the extension could have any kind of value, is only allowed to have a string. That's basically the only thing we have to put right there. That's pretty much it. I mean, additionally, you could, of course, add more constraints on the value of your extension. For example, if your extension had a codable concept, you might also add a value set binding. But with a string, there's pretty much nothing else that we would put there. Maybe we could put a constraint on the length of that string. But yeah, let's keep it simple. Let's just run the compiler. Did I close my command line? Why did I close it? What happened? SUSHI. There you go. Let's see what happens. In parallel, I could also put this in the simplifier sandbox again to see a graphic representation of our extension. And now you can see here's our extension with, you can see the fixed value is already set to the canonical URL. Difference is that the canonical URL here has automatically defaulted to example.org because we don't have a SUSHI config file in that tool. So there's nothing you can really do about it. When you use that tool, your canonicals will always start with example.org. But you can see that it now created an extension with a value string. Same happened locally. I have now a structure definition for my planet extension. Again, the compiler in the background has taken care of all of the metadata. It's used a default context, which basically says that you can slap this extension on any element that you like, which is maybe not a good idea. We should take care of that. And other than that, it's basically adding the definition of that particular extension. So in order to make the context more specific, we can put the context header and say where it is appropriate to use this extension. In our case, we would want this extension only to be used to extend the address data type. We wouldn't want a planet extension just randomly slapped on a patient or something. So let's do that. And now, of course, we have to add the extension to our patient profile. And we're doing that by saying that the extension element, oh, hold on, that's wrong. The address dot extension element contains And now we put the name of our extension, say, in the list of all the potential extensions that an address could have, we want one of those extensions to be our planet extension. And we can also assign a name, like a label that we want to display in the context of our profile. Let's just display this as planet. And then we can assign a cardinality. We can decide whether we want multiple planets to be put on an address, which is kind of nonsense. We would have a max cardinality of 1. But we could decide whether planet is optional or mandatory for a given address. So let's just say we want to make the planet extension mandatory and set the minimum and maximum cardinality to 1, and also add a must support flag to indicate that implementers need to understand what a planet extension is all about. And that would actually be the way to accomplish that. But if we say that having a planet extension is mandatory, we have to make sure that our patient also has an address with an planet extension, and now we just put the name of the extension that we assigned into brackets, and then we can assign our value Earth. I think we have to put a value string on there. Do I have to? Let's see. Yeah, I have to put dot value string and assign a value to that address. See if that works. It's looking good. So again, let's run it through this tool to get the visual output. Oops, it doesn't like the context element. I think that's a new addition to the syntax. Might be an older version of SUSHI running here. Okay, so now you can see our patient profile with the address carrying the planet extension as a mandatory element. And you can see that our patient also has an address element with a planet extension, again, as a key value pair where we have the unique key, the unique name of that extension, and the value, the string value that we transport with the extension. Just because we only have 1 minute to go, I will answer questions during the break time. That's no problem at all. But let me just point you back to the slides. We didn't make it through all of the exercises that I actually intended to do. There's still a lot more possibilities, for example, creating value sets and slicing elements in profiles and stuff like that. I will actually send you a full exercise with some annotations of all the stuff that we didn't manage to do today, so you can look at the example and figure it out by yourself on how it works. I will share that a little later today in the chat. I will just have to clean up my code and then I will share it with you. But you can also find a lot of resources online. If you want to continue working with FHIR Shorthand, you will find a very nice tutorials on fishschool.org. They really have nice materials to learn. Then, of course, there's the original FHIR Shorthand specification if you want to look up any details on the syntax of the language. However, I recommend to print out the cheat sheet that is linked here for a quick reference to look up the syntax of FHIR shorthand. That's really very helpful if you use FHIR shorthand in your everyday life and you have to look up specific keywords or something like that. That's really helpful. There's also a dedicated Zulip stream for people who use FHIR shorthand and run into issues where you can get help from the experts. But of course, you can also send me a direct message through Zulip or through the Hoover app if you have any questions after the tutorial. Please feel free to give feedback as well. I'm happy to hear from you what I can improve with my trainings. Of course, it would have been nice to have more time. We could spend a whole day doing FHIR shorthand training. Again, I'm happy to stick around for another couple of minutes to answer questions. I think there was a question over there. Oh, sorry, it was you. I'm sorry, I'm getting confused.
Thank you very much for a nice presentation.
Thank you.
I was just wondering if there's any tool, any autocomplete help that exists, either as an extension in VS Code or any other editor that provides that, because I think it would be very useful.
I think the extension that provides the syntax highlighting, stuff like that, is only available for Visual Studio Code. I'm not aware of other tools that have similar kind of extensions. Yeah, unfortunately. Might be some projects around there, but none that I'm aware of. Yeah. But again, the Fish Online tool also has a little bit of syntax highlighting, so you can always use that if you, for some reason, don't want to use Visual Studio Code. There's also one very neat thing that I wanted to show you. Let's just do that really quick. If you get stuck, if you want to do something and you don't know how to accomplish it with FHIR shorthand, but you know of a profile or a resource where someone did just that. Like, for example, a particular kind of complex slicing that is happening in a profile, or a sophisticated extension, and you just can't figure out how to recreate that with FHIR shorthand. You can also use a reverse compiler. You can actually pick with the Fish Online tool, you can take any resource that you find out there, any profile, any structure definition in JSON format, and you can paste it into the right-hand panel, and then you can click the Convert to Fish button, and it will create the corresponding fish code that created that instance. And that's very nice if you want to learn from what other people did, and if you want to figure out how to do specific things in FHIR shorthand. Because it's always, I think for implementers, it's always easier to learn from other examples than actually reading through specifications, right? So I use that quite excessively, that tool. That's very helpful. And also, if you had a little bit more time, what's really fun is to actually ask ChatGPT to create FHIR shorthand code for you. But be really careful, because sometimes it really messes up bad. But what I found really helpful is any stuff that is cumbersome, where you really have to type lots of lines. Like, for example, you want a value set. I actually tried that earlier because I wanted to show it to you. Is I asked ChatGPT to create a code system with all of the different species in the Star Trek universe. And it did actually quite a nice job listing, you know, the Klingons, the Romulans, and stuff like that. And I could actually just copy and paste the list of codes. The metadata was a bit messy, but the list was actually quite usable. So that's always a fun thing to do, is to basically ask ChatGPT to create a patient with a specific diagnosis using FHIR shorthand. And it will usually create something that you can start from. You probably have to correct a few syntax errors, but other than that, it saves a lot of work. Yeah. Any more questions?
I think some people are really looking to go for lunch, but maybe the rest of the questions we can do just here with you, like informal.
Yeah. I think we also have a lunch table where you supposed to ask questions. I just have to figure out which table it is. So yeah, there's like topic-based tables, and there should be one lunch table specifically for FHIR shorthand and implementation guide creation, and I will meet you there if you want to ask any additional questions.
Thank you, Simone.
Thank you.